Hi, I'm Brian Givens, creator of dbiScript, and welcome to the dbiScript Medical Practice Management tutorial. In this tutorial, we'll be using dbiScript to create a browser-based, graphical user interface to a database customized for a fictional health clinic. This is the second video in the series. If you haven't already watched the dbiScript Northwind tutorial, you may want to do so before watching this tutorial. In this video, we'll be focusing less on the relational features of dbiScript and more on the 26 different dbiScript field objects. Before we begin, you want to switch YouTube to the maximum streaming resolution by first clicking on the little gear icon towards the bottom right hand corner of the YouTube window. Then, select Original from the list of options. That's a resolution of 1920 by 1200. And finally, click on the full screen icon at the very bottom right hand corner of the YouTube window. Here's our first look at the completed dbiScript Medical Practice Management application. The first thing you'll probably notice is that it is much more complex than the dbiScript Northwind application. However, I think you'll find that the dbiScript code behind the application is remarkably concise and easy to follow. Now we'll take a look at that dbiScript code. The application consists of 16 data tables and 6 supporting tables. The supporting tables are listed up here at the top, and then for data tables we have patients, insurance companies, doctors, referring doctors, attorneys, submitters, insurance policies, patient policies, transactions, disability, ambulance, co-payments, allergy, medication, procedures, and the system table. Now let's take a look at the relationships that have been defined between the tables. The first several tables in our application are unrelated. The first relationship is between insurance policy and insurance company. Next, patient policy is related to both patient and insurance policy. Transaction is related to the patient policy. Disability is related to the transaction, as is ambulance. Co-payment is related to patient, as is allergy and medication. And finally, procedure is related to the transaction. Now let's see how all these relationships affect the dbiScript interface. As always, dbiScript automatically handles all the relationships in the application, and the entire interface you see here is generated on the fly. Now you recall that the patient policy is related to both insurance policy and patient, and the insurance policy is related to the insurance company. In the interface which dbiScript is automatically generated based on these relationships. To get to the patient policy, we first select a patient, then an insurance company, and finally the insurance policy. Or we can go straight from the patient to the insurance policy, or from the patient to the patient policy. Again, all these relationships are handled automatically by dbiScript. You may have noticed that the patient policy table behaves slightly differently from the other tables we've previously discussed. Normally, the patient policy would appear as a tab in the page frame beneath the insurance policy page frame. However, in this application, the patient policy is a special case because its relationship has been defined as having a maximum of 1 record per unique combination of foreign keys. In our dbiScript application code, we specify the maximum number of records being 1 as the last parameter of the append data table function for the patient policy. Since we're only allowing 1 patient policy per unique combination of insurance policy and patient, in this configuration here, we can pull the patient policy information into the insurance policy row. Similarly, in this application, our disability and ambulance tables are limited to 1 row per transaction. So the disability and ambulance information is displayed within the row of the transaction. In our selected transaction here, we can see the ambulance information, but there is no disability information. This is because no information was entered into the disability row for this transaction. When the transaction is edited, the disability row appears. If we add information to the disability and save the changes, the disability row now appears along with the transaction. To delete the disability, we can either click on the Delete Disability icon, or edit the transaction, remove the disability information, and save our changes. Now it's time to take a closer look at the dbiScript field objects. I'll start with the photo album, and then I'll go alphabetically through the others. The patient table has two attached photo albums which are initially hidden from view. Clicking on the Show Photos icon will display the photo albums. The select at the top of the photo albums indicates which photo album is currently displayed. The selected patient does not currently have any photos in this album. To add some photos to this patient's album, we'll edit the record and then click on the Add Photos icon. Now we can either click on the Add Files button and select files using the browser's built-in file selector, or we can drag and drop files from the desktop or from anywhere within the operating system file selector into the Upload Images dialog box. The drag and drop functionality I've just illustrated is part of the HTML5 spec and is unfortunately not supported by all browsers. It is supported in Google Chrome, which I'm using for the tutorial, and also Firefox, and Apple Safari. However, because Apple Safari does not support the full HTML5 spec, here we do not get the nice little preview images that we saw in Google Chrome and Mozilla Firefox. Drag and drop functionality is not currently supported in any version of Internet Explorer, nor is it supported in Opera. Additionally, Internet Explorer does not support the multiple option of the HTML file input. So with Internet Explorer, we have to add images one at a time to the Upload Images dialog box. Since Opera does support the multiple option of the HTML file input, we can at least select multiple files at once in Opera. Once we have all the files we want listed in the Upload Images dialog box, we can make any changes we want to the description of each image. And then to begin the upload, we just click the Upload button. When the photo albums row is in edit mode, clicking on the displayed photo brings up the Organize Album window. In this window, we can view thumbnails of the photos in various sizes, change the order of the photos within the photo album, rename photos, and also upload more photos or delete photos. When the photo albums row is in display mode, clicking on the displayed photo brings up the full screen photo album, where we can navigate through all the photos at full resolution. And finally, we can once again hide the photos by clicking on the Hide Photos icon. Now we'll discuss the other field objects in alphabetical order. Most of the field objects support several optional properties, which modify the behavior of the object. All of these properties are well documented in the dbiScript Programmer's Reference Guide. As we continue our discussion of the field objects, I'll show the relevant properties in the reference guide, but I won't be discussing every property in detail. Our first field is the age field, which simply attaches to a date field in the row and displays the age in years of the date. In edit mode, the age reflects the current value of the date to which it is attached. The age field does not currently support any optional properties. However, it, along with all the other dbiScript field objects, will continue to evolve over time. Our next fields, the aggregate and aggregate money fields, support several options. So we'll flip forward in the manual to where they're discussed. In our medical practice management application, we have an aggregate money field on the insurance policy, which displays the sum of all the charges of the procedures related to the insurance policy. In the interface, this field appears in the rightmost column of the inline row of the insurance policy. As with all calculated fields in dbiScript, the aggregate and aggregate money fields are read-only and appear identical in display and edit modes. Whenever a change is made to the data involved in an aggregate function, the change is immediately reflected in the dbiScript interface. The next dbiScript field object is the Boolean field. We have several Boolean fields in the patient table. In display mode, the value of the Boolean field is indicated by either a check mark for true or an X for false, or if you prefer, a blank for false. As with all dbiScript fields, if the field is a drill down field and there is no value to display, then the field's caption appears grayed out in the row. The dbiScript Boolean field is a 3-value field which can store true, false, and also null if the underlying database field allows null values. The underlying database field can be a Boolean field in those databases which support it. Alternatively, it can be a numeric, char, or varchar field. In edit mode, the dbiScript Boolean field appears as a button, which cycles through the available values when clicked. When the button has focus, the Enter key on the keyboard can also be used to cycle through the available values. Our next dbiScript field is the button field. The button field simply displays a button. In this application, we use the button field for the map column of the patient table. When clicked, the button opens a new tab in the browser, the URL of which is specified in the field's onClick data-driven function. Next is the copy button dbiScript field object. As the name implies, the copy button provides a means to copy a row to another table in the database. The table we're copying to does not need to appear in the dbiScript application. The name of the table we're copying to is specified in the parameters of the append copy button or the append drill down copy button function. Additionally, in the parameters of the copy button function, we can specify descendant tables. When a descendant table is specified and mapped to another table in the database, the related descendant rows will be copied along with the parent row. In the interface, the copy button only appears in the display view of the row, and the process of copying a row is just click and confirm. Our next dbiScript field object is the datetime field. The datetime field is instantiated by either the append data or the append drill down data function, where the underlying field data type is datetime or timestamp. By default, the time portion of the stored datetime value is not displayed. However, this can be changed if desired by setting the field's showTime property to true. In display mode, the field value is formatted as shown in our application's patient date of birth. The datetime field has a lot of features in edit mode, so we'll scroll forward in the manual to where these features are discussed. This table details the effects of the showTime, showSeconds, and showTimeZone properties on the datetime GUI, and these are the keyboard shortcuts available when entering a date. Now we'll look at the datetime field in edit mode. The pop-up calendar appears immediately when the date input receives focus, and the calendar is set to the current date of the field. The month displayed in the calendar can be set forward 1 month by clicking on the right pointing arrow, or set backward 1 month by clicking on the left pointing arrow. Holding down the Shift, Control, or Alt keys while clicking on this left arrow will set the calendar back 1 year. Doing so while clicking on the right arrow will set the calendar forward a year. Clicking on the calendar year brings up a scrollable display for changing the calendar year. And clicking on the calendar month brings up a scrollable display for changing the month. And of course, the input date is changed by clicking on any date in the calendar. The date input keyboard shortcuts are browser dependent. Here we're using Google Chrome. Note that in all other browsers, the Control key takes the place of the Alt key in all the following examples. So the Alt plus left arrow key combination subtracts 1 day from the current date. Alt right arrow adds a day. the up arrow subtracts a week, down arrow adds a week, page up by itself subtracts a month, page down adds a month, alt page up subtracts a year, and alt page down adds a year. Additionally, the date input recognizes most text date formats, as well as the closest date shortcuts. For example, my entry here will be resolved as the closest July 1st to today's date. For a single number, closest date shortcut example, the closest 30th of the month to today's date is May 30th. Now we'll move on to our next dbiScript field object, the email field. The email field stores an email address. In display mode, the email field behaves as a normal email link, which when clicked, launches a new email in the user's email client. The CC, BCC, subject, and body of the new email can be set statically with the field's optional properties or dynamically with the field's data-driven functions. As an example, in our application, we have an email address on the insurance company where the subject is set dynamically. Now when we start a new email, you'll notice that the subject has been dynamically set. Another noteworthy feature of the email field is invalidation and verification. By default, dbiScript will warn the user whenever they've entered an email address which appears to be invalid. Here we'll edit the address as if the user has forgotten the dot in .com. When we attempt to save the row, we're first warned that the email address may not be valid. The user can then choose to either ignore the warning or modify the entry. Now I'll just take a quick look at the other optional properties of the email field. And we'll move on to the file vault dbiScript field object. The file vault field stores a single file for the row. An optional description can be stored for the file in the database and displayed in conjunction with the file name. Whenever a new file is uploaded for the row, the previous file can either be archived or deleted. Files can be checked out, which prevents other users from uploading new files. When the file is checked out, the file field displays the user ID of the user who has checked out the file, in addition to when the file was checked out. In our application, the patient's patient file is a file vault. I'll go ahead and upload a file into this row's patient file now. The uploaded file can then be checked out by clicking on the Check Out button. This prevents other users from deleting the file, uploading replacement files, or checking out the file themselves. I'll quickly log in as another user. Here you can see how the file vault appears to other users while the file is checked out. Note that development is the user ID assigned by dbiScript while the application is in development mode. When the user no longer requires exclusive access to the file, they simply check it in. And at any time, the file can be deleted by the user that has checked out the file, or by any user if the file has not been checked out. Now we'll take a quick look at the file vault's optional properties. And move on to the icon list dbiScript field object. The icon list displays a set of icons, the display of which can either be set by the user and stored in the database, or the display can be set by the field's data-driven calculate function. The icons used are chosen by the developer and can be any image of the appropriate size, the meanings of which are unique to each individual dbiScript application. Our patient icons use 4 icons: a.png, which is a cactus, b.png, which is a ladybug, c.png is a lightning bolt, and d.png is an alarm clock. The field is a calculated field, and in the field's data-driven calculate function, we return an array which specifies which icons to display for the field. What we've done here is define a regular expression which looks for the letter A in the row's last name, first address field, city, and state. So if the letter A is found in the last name, then a cactus will be displayed. If there's one in the first address field, then there'll be a ladybug. If there's one in the city, then there'll be a lightning bolt. And if there's one in the state, then an alarm clock will be displayed. Back in our application, we can see how the icons displayed for Mr. Boyd are the ladybug, lightning bolt, and alarm clock because of the letter A, which appears in the first address field, the city, and the state. If we wish to change the field from a calculated field to one where the user can specify the display of the icons, we must first change the name of the patient icons calculate data-driven function so that it's no longer tied to the field. Then, we add some information to the append icon list function, which specifies the link table where the data will be stored. Now we'll refresh the browser, and at this point our icons column will appear empty because we have not entered any data for the field. So we'll edit a row, display some icons, and save our changes. The type property of the icon list supports 3 values. In this mode, dynamic, which is the default, the user can also specify the order of the icons. The other 2 modes are static and all static. Now I'll revert to the calculated icons. And we'll move on to the memo dbiScript field object. The memo field is designed to handle large amounts of text data. It must appear in the drill down portion of the row and is instantiated by either the append drill down memo function or the append drill down data function where the underlying database field size is greater than or equal to the field's force memo field size property. In our application, we have a memo field on the patient notes. When there's a small amount of text in the field, as there is here, the field floats within the drill down just like all the other fields. In edit mode, the memo field is an HTML text area, the number of rows of which can be specified in the memo field's properties. We'll enter a large amount of text into the field and save the row. Notice how the display field adjusts to accommodate all the text. Now we'll take a quick look at the memo field's other optional properties and move on to the memo preview dbiScript field object. The memo preview field is a read-only field which simply displays as much text from its field as will fit into its data table column. The memo preview is always an inline field and is instantiated by either the append memo preview function or the append data function where the underlying field size is greater than or equal to the field's force memo field size property. In our application, we have a memo preview on the insurance company notes. Note that to enable editing of the row, the notes have also been appended into the drill down of the row. Next, I'll discuss 3 closely related dbiScript field objects, the money, number, and percentage fields. As the name implies, the money field displays its field value as currency formatted text. The number field displays a simple number, and the percentage field displays its field value as percentage formatted text. In our application, we have 2 money fields on the procedure table, one for the insurance charge and one for the patient. The money, number, and percentage fields are fairly straightforward, but they do have a lot of options, so we'll scroll through them now, beginning with the money field options. We'll come back to the Move button. Here are the number field options. And finally, the percentage field options. Before we move on to the pick list field, I'll briefly discuss the Move button dbiScript field object. The Move button provides a means to move a row from one table in the application to another table in the database. The Move button field is virtually identical to the Copy button field, with the exception that the selected record is moved to instead of copied to the other table. The PickList dbiScript field object enables the user to select a list of items from a master list stored in a definition table of the application. In our application, we have a pick list on the patient diagnosis. The items of the displayed list are separated by a comma, which appears in a slightly different font from the rest of the text. This is done so that a comma that appears within a list item, such as sprain, knee here, can be distinguished from the comma separating list items. In edit mode, clicking on the field's Edit button brings up the pick list window. In this window, the selected items are shown in the right-hand list, while the left-hand list shows all the master list items that have not been added to the selected list. An item can be transferred from one list to another by double-clicking it, and the buttons in the middle can be used to move an item to or from the selected list, or all items to or from the selected list. Now we'll take a look at some of the options available to the pick list field. If we set Allow New to True, then the user will be able to enter new items for the pick list, which will be stored in the field's underlying definition table. I'll go and set Allow New to True on the patient diagnosis, so we can see how this affects the field. So now we have this input for adding new items. I'll go ahead and add a new item to the pick list, and you can see how the item is added to the list of selected items and is highlighted to indicate that it is a new item. And then when we click OK, the new item is added to the list. Another interesting property of the pick list is data order. When set to the user value, the user can then specify the display order of the items in the selected list. I'll again modify the patient diagnosis to illustrate this. As you can see, we have two new buttons between the lists to move an item up or down in the selected list. I'll move leg pane up, click OK, and you can see how the display respects the set order. Now we'll scroll through to the end of the pick list properties. Now I'll demonstrate the pick list field's type property. By default, the pick list type is string, which we've seen in the patient diagnosis. Now I'll go and modify that field's type property to table. As we can see, the position of that field in the drill down is a bit awkward. However, if the table version of the pick list is preferred, then moving that field to be the first field in the drill down will improve the display. Now I'll revert those last few changes and we'll move on to the Quick Pick dbiScript field object. The Quick Pick field enables the user to quickly select an item from what is typically a large list of items. The list of items for the Quick Pick field can be populated from either the physical field to which it is attached or from a definition table. In our application, we have a field value Quick Pick on the patient city. As we begin typing into the field, a select appears listing all of the items matching the entered text. We can continue typing or at any point use the arrow keys and then enter to select an item from the list. Optionally, the mouse could have been used to select the item from the list. The icon to the right of the field provides some feedback on the state of the field. The green vertical bar indicates that the text we have entered matches an item that already exists in the table. If we enter text that does not exist in the table, then a green N is shown to indicate that it is a new item. New values are always allowed in field value quick picks. Allowing new values in definition-based quick picks is optional. In definition-based quick picks, if new values are not allowed and we enter text that does not exist in the table, then a red N is shown. In our application, we have a definition-based quick pick on the medication description. This is a much larger list than patient city, but navigation through the list is just as quick. The medication description is configured to allow new items, so I'll demonstrate adding one. This new description has now been added to the definition table for the field. Now we'll take a quick look at the quick pick field's other optional properties before moving on to the radio dbiScript field object. The radio field enables users to select an item from what is generally a small list of items. Since the list is generally just a few items, the radio field accepts a hard-coded list. However, the list can also be pulled from a definition table. In our application, we have a radio field on the patient gender. In our code, the isRequired property of that field has been set true. If we remove that setting, it will now be possible to clear that radio field. Another interesting dbiScript function that I can demonstrate here is the isDisplayed data-driven function. The isDisplayed data-driven function is available to every drill-down field. In our application, the patient table has a field to store the patient's date of last menstruation. This field is only displayed when the patient's gender is female. In the isDisplayed data-driven function for the last menstruation field, the value true is only returned when the patient gender is female. This is a very simple but powerful function of dbiScript. If a date is set here, and then the patient's gender changed to male, the field's value is not immediately discarded. If we again set the gender to male and save the row, only then is that value discarded. Another feature is that a radio field can be linked to another radio or select field. We'll discuss this feature further when we get to the select dbiScript field object. Now I'll revert that change, and we'll move on to the row state dbiScript field object. The row state field provides a means for the user to set state information about the row. When a row state field is an inline field, it also provides a means for the user to quickly filter the rows by this state information. By default, the row state field is a 3-value field, the display of which alternates between 2 icons which ship with dbiScript, plus a blank display for a null value. However, any number of icons can be specified for the field, with each icon indicating a different state for the row. The underlying database field type should be the smallest integer data type supported by your database, such as tinyInt. The value stored for the field will be the index of the user-selected icon from the icons property of the field. In our application, we have a row state field on the first column of the patient table. This field indicates whether or not the patient is an active patient. You'll notice that the header of the column contains the filter button and no text. However, text can be added if desired. In edit mode, the field is a button. The values of the field are cycled through by clicking on the button or pressing enter on the keyboard while the field has focus. You may have noticed that while cycling through the values of the field, whenever I set the patient as inactive, the patient's inactive date was set to be the current date. This was achieved by setting the inactive date's update value data-driven function. Now I'll save the changes, setting the patient as inactive, and I'll demonstrate the field's filter button. Initially, the filter is set to display only active patients, and while we've just updated Mr. Boyd to be inactive, we'd have to refresh the page in order for him to be excluded. Now if I click on the button, the filter will be set to display only inactive patients. Another click and the filter is set to display all patients. And one more click to bring us back to showing only active patients. And now we'll go through the process of making Mr. Boyd active again. And now we'll move on to the reference dbiScript field object. The basic use of the reference field is to store an optional foreign key for the row. In our application, we have reference fields on the patient's primary and referring physician, as well as the attorney. The reference field displays a configured string from one or more fields of the selected row in the reference table. Configuring the string can be as simple as specifying one field from the reference table, or the field's data-driven format function can be used to return a string composed of any data from the referenced row. Additionally, several data-driven format functions can be defined for the reference field, so that in edit mode, the reference field's built-in quick pick can be used to navigate the reference table by different field orders. The field's magnifying glass icon is used to toggle the display of the entire referenced row. In edit mode, the Change Format button is displayed if multiple data-driven format functions have been defined for the field. For the referring physician, the first function returns a string composed of the doctor's last name, first name, and middle initial in that order. The second function returns a string composed of the doctor's first name, middle initial, and last name in that order. The field order of the active format function is used for text searches. The field's Edit button opens the reference table in a new window. This window provides full access to the reference table. In other words, rows can be added, updated, and deleted here. And of course, it can be used to select a new row for the reference field. In the patient table, we also have a reference field on Referred By. This reference field is interesting because the table it references is also the patient table. This is what I call a self-referenced reference field. We don't have a value set here for Mr. Boyd, but if we take a look at Mr. Croman, we see he was referred by Mr. Boyd. As always, the magnifying glass button toggles the display of the full referenced row. Whenever there's a self-referenced reference field in a table, dbiScript will always add a tab to the next page frame, which lists in this case the patients that were referred by the selected patient. In this case, Mr. Croman hasn't referred anyone, but Mr. Boyd referred Mr. Croman. Similarly, dbiScript will automatically add a patient tab to the next page frame for the physician, referring physician, and attorney, in each case displaying the related patient rows. To recap, reference fields are basically optional foreign keys, and dbiScript takes these relationships into account when automatically generating the interface for the application. Now we'll quickly scroll through the reference field's optional properties. And move on to the Select dbiScript field object. The Select field is similar to the Radio field in that they're both designed to enable the user to select an item from a relatively small list of items. Both fields can be populated from either a hard-coded list or from a definition table-based list. The Select field is suited to larger lists than the Radio field. It also has the advantage of optionally allowing new items to be added to the field. In our application, we have several Select fields on the patient table. In display mode, the text of the selected item is displayed. In edit mode, the field is an HTML select object. For definition-based selects, the field's code property may also be specified. The code property specifies a field to retrieve for each item in the list along with the description. When the code field is specified, its value is displayed in brackets in the text of each item. The code can be left blank, in which case no brackets are displayed. However, if the code is one or more characters, then the keyboard can be used to directly select an item by entering its code. For example, to add new items to the field, there are two options. The first, New Item, enables the user to add a single new item to the field. When a code has been specified for the field, the new item is separated into two inputs, the first of which is for the code, and the second is for the description. When a single new value is entered, it's added to the definition table when the record is saved. To add several new items at once, select New Items from the list. Here, we can add several new options at once. And these options are added to the definition table as soon as we click Save. Notice that the source is now the first item that we entered in the options window. As with the radio field, the select field can be linked to another radio or select field. The linked parent table can appear in the same table or any ancestor table of the linked child fields table. To demonstrate linked fields, I'll use the table and fields permissions tables, which are part of dbiScript security and are accessed through the Users or Groups tab of any dbiScript application. Between these two tables, the table name field is linked to the field name field. The field name select is not populated until a table name has been selected. Selecting a field name locks the table name to the selected value. Resetting the field name enables the table name to be changed. In this example, the linked fields appear in separate but related tables. Another common use of linked fields is in a country-state arrangement, where of course the linked fields appear in the same table. And again, the linked fields can be either radio or select fields. So with our country-state example, we could use a radio for the country and a select for the state, or any preferable combination of radio and select fields. Additionally, multiple fields can be linked, so that a parent field can be linked to multiple child fields. Now we'll take a quick look at the select field's other optional properties. And we'll move on to the string dbiScript field object. The string field will be the most ubiquitous field object in most dbiScript applications. It is instantiated by the append data function or the append drill down data function, where the underlying database field type is car or varchar. In our application, we have several string fields in the patient table, such as first name, middle initial, last name, address, and several more. In display mode, the string field simply displays the text of the field value, and in edit mode, the string field is an HTML input. The string field supports several optional properties. When we discussed the memo field, we saw how the allow force memo and force memo field size properties of the string field are used by dbiScript to force a memo field whenever the underlying database field data type matches certain criteria. Another interesting property of the string field is the input mask. The input mask provides a means to both format and verify the data in a string field. In our application, all of the phone number fields in the patient table specify the same input mask string. This input mask restricts entry to either 7 or 10 digits and formats the phone number as per the North American standard. The programmer's reference guide includes a full discussion of all the input mask control characters. Back in our patient table, we'll edit a phone number to see how the input mask is applied. Note that in the database, only the digits of the phone number are stored. The formatting is applied by the input mask. If we enter a phone number that is neither 7 nor 10 digits, the value will fail the input mask validation when we attempt to save the row. Now we'll head back to the string field's optional properties, and we'll take a quick scroll through the rest of these properties. And we'll move on to the tree view dbiScript field object. The tree view field provides an interface through which the user can select an item from which is typically a large list of items organized into a hierarchical structure, which is commonly referred to as a tree view. In the patient table, the tree item field is a tree view that I've added just to demonstrate this field object. The tree view window is displayed in edit mode by clicking on the field's edit button, or we can get there directly by clicking on the field in display mode. The first thing you'll notice is that the tree has been automatically opened to display the field's currently selected item. There are a lot of keyboard shortcuts for the tree view. A list of all the shortcuts is provided within the interface. I'll demonstrate a bit of navigation through the tree view, first with the keyboard. And now with the mouse. The description of an item can be edited by clicking it. An item can be dragged and dropped to a new location in the tree. And some functionality is available through the right-click menu. Also available from the right-click menu is the search window. Back in display mode, the text of the item does not by default show the path of the item in the tree. However, we can change this by setting the field's display path property to true. Now I'll demonstrate this in the tree item field. So now the full, and in this case very long path to the item is now displayed. I'll just revert that change. And we'll do a quick scroll through the rest of the tree view's optional properties. And now we'll move on to the URL dbiScript field object. The URL field simply displays an HTML anchor in display mode, and in edit mode the field is an HTML input where the URL can be modified. In our application, we have a URL field in the insurance company table. I'll go ahead and change this company's website. And as you can see, in display mode, it behaves like a regular HTML anchor. There are just a couple more optional properties to the URL field. Like many of the dbiScript field objects, the URL field can be a calculated field, and it can also be a read-only field which would be populated by a database stored procedure. Additionally, the URL field supports a format URL data-driven function. With the format URL data-driven function, the URL field is edited exactly as I just demonstrated. In display mode, only the field value is displayed. However, when the anchor is clicked, the actual navigated URL can be modified to include any data chosen from the row itself and all related rows. This concludes the dbiScript medical practice management tutorial. Thank you so much for watching. I hope you've enjoyed this overview of the dbiScript field objects. Also, I hope that what I've shown of the dbiScript Programmer's Reference Guide has demonstrated how easy it is to learn and use the dbiScript programming language. While it's not practical to cover every detail of the 160-odd page Programmer's Reference Guide in video, be assured that the rest of the manual is as straightforward and easy to follow as what I've shown here today. In developing the dbiScript field objects, I tried to ensure that dbiScript could handle any scenario I'd come across in my 10 years of application development prior to starting dbiScript. I hope you'll find what I've come up with to be not only useful, but also extremely easy to use. My overall goal for dbiScript has always been to make the process of creating custom database applications as painless as possible. If this video has inspired you to become a dbiScript developer, then your feedback is what will drive dbiScript forward. As dbiScript evolves, I'll be relying heavily on developer feedback when designing new field objects for dbiScript, in addition to enhancing the dbiScript field objects I've presented here. Once again, thanks for watching, and I hope you join me for the next tutorial on application security. Until then, I'm Brian Givens, signing out.